Hello friends, welcome to Knowledge Galaxy to rediscover the basics with Mayank Tiwari, a premier coaching and training channel dedicated to metallurgy studies and consultancy. Established to cater the needs of students, degree, diploma and AM/IIM metallurgy, competitive and recruitment exams for GATE, SAIL and various other government and private sector companies, metallurgical industries, working and aspiring professionals and whosoever seeking knowledge and information about various subjects and topics of metallurgy, ferroalloys, operational process optimization, productivity improvement analysis, etc. To impart practical industrial knowledge as per your specific requirements via tailor-made training sessions for your colleagues, employees and students, please contact me on knowledgegalaxy26@gmail.com or WhatsApp me on +91 99 071 44 101 for scheduling and organizing the sessions at your place or via video conferencing. My dear friends, nowadays technology has improved so much that actual physical distance doesn't matter anymore. You can get all your doubts cleared by sitting at your home, at your comfort zone, just by contacting me over WhatsApp or phone, so that for your benefit, please do contact me for any of your doubts. My dear friends, I have made so many videos which are available on my YouTube channel, so I request you to visit my channel regularly and repeatedly and watch all the videos available there, so that you can gain maximum knowledge about the subject and topics, and also request you to watch all my videos from start to finish, so that you can gain the maximum and complete knowledge about the topic. My dear friends, as you know that training is costly, but not to train is still costlier, and when you are not having complete knowledge or don't get any information about the topic which you need to know, so you can contact me. If you don't find anyone who can help you to clear your doubts, you do contact me as soon as possible. And so right now in this video I am discussing about in this present video, I am going to describe about yet another very important equipment of ferroalloys production, and that is the electrodes for submerged arc furnaces. These electrodes are considered as the heart of the submerged arc furnace. As the heart is important for the human body, so is the electrodes for the submerged arc furnaces. So before I proceed to the main topics, I would like to request you all to watch all the video in the next slide and follow this message. As you have seen and observed in the video that no water can be filled in the pot if the pot is not aseptic, and also if the pot is already filled. The water can only be filled when there is some space in the pot. So my dear friends, I request you to keep your minds open for receiving the information, so that you can receive the information correctly and gain the knowledge. But if you feel that you are already having much knowledge or more knowledge, or if you are not receptive towards receiving the new knowledge or information, you cannot gain anything. So for gaining new knowledge and information, please keep your mind open and be receptive for the new knowledges always. So now let us proceed to the main topic and let us see what is this topic is all about. So to start with, carbon electrodes. Carbon electrodes, as I have acronymed earlier, that carbon electrodes are considered as the heart of the furnace. Carbon electrodes are of two types. You might be knowing that the first one is self-baking Soderberg type and the other is pre-baked graphite type. Self-baking Soderberg type electrodes are preferably used in ferroalloys furnaces due to the following reasons. First, cost of production of self-baking Soderberg type electrodes is less as compared to pre-baked graphite type, because no need to consume time, energy and money for its manufacture. I hope you might have heard about this very long ago and many times. But why the electrodes of Soderberg type are majorly used in ferroalloys production is the main reason why, and the details of which I am going to describe in this presentation. This presentation will clear all your doubts regarding carbon electrodes, its manufacture, its properties. So I will try to clear all your doubts with this presentation, and I hope this video will be very much helpful for you to know about the electrodes for submerged arc furnaces. Okay, let's proceed. The electrode paste is fed in the mild steel casings in the size range of 25 to 75 mm briquettes or 50 kg cylinders. It gets baked by the heat of the process itself and forms the electrode, thereby eliminates the need of separate baking. This is why it is called self-baking Soderberg type electrode. Operationally also, it is very convenient to use, since self-baking Soderberg type electrodes are continuously fed from the top based on the consumption, without any need to switch off the furnace for feeding the electrode paste in the mild steel casings. So all these parameters, all these reasons justify the use of self-baking Soderberg type electrodes in submerged arc furnaces. I hope it is clear to you all. Okay, now let's proceed. So to first start with, let us first consider the role of electrodes and the requirements they should fulfill. Electrodes serve to supply the electric current to the working space of a ferroalloy furnace and constitute one of the main elements of its design. The physical and chemical properties of the electrodes essentially affect the quality of the smelted products and the performance data of the ferroalloy production. Continuous self-baking electrodes, that is Soderberg electrodes, which have supplanted carbon electrodes wherever carbonization of alloys or their dilution by iron is permissible, are widely used at present. Carbon electrodes are not employed in the ferroalloy industry at present, while graphitized electrodes are used in the production of decarbonized ferrochrome, metallic manganese and crystal silicon. Electrodes should possess high electrical conductivity, sufficient mechanical strength, high oxidation temperature, low disintegrating capacity and low cost. These are the major parameters to choose or major properties of a self-baking Soderberg type electrode. Ring electrodes are generally used to ensure a reliable contact between the electrode and the clamp. The shape of the electrode should be geometrically perfect. Ferroalloy smelters normally use electrodes ranging from 250 to 1400 mm in diameter. The physico-chemical properties of graphitized electrodes are as follows. First, ash content 0.1 to 1.0%. Next, apparent specific gravity 1.50 to 1.70 gram per cubic centimeter. True specific gravity 2.20 to 2.21 gram per cubic centimeter. Porosity should be 28 to 30%. Mechanical strength in compression should be 160 to 300 kg per square centimeter. Specific electrical resistance should be 8 to 12 ohm millimeter square per meter. The characteristics of anode paste for the self-baking electrodes used in various smelters of former Soviet Union are shown in the table below. Along with this, carbon electrode characteristics are also given for the comparison. My dear friends, I have populated this table so that it is very much useful for you all to understand the various properties about the electrode anode paste. You can pause the video and observe the table contents. Okay, let's proceed. The table above shows that the quality of self-baking electrodes is almost equal to that of carbon electrodes. Permissible current density equals amperes per square meter. For carbon electrode is 5 to 11 amperes per square meter. For graphitized electrodes it is 13 to 28 amperes per square meter, and for self-baking electrodes it is 5 to 7 amperes per square meter. Maximum current values correspond to electrodes with smaller diameters. Let us now discuss about manufacture of electrodes, how they are manufactured, what are the important steps. The electrode manufacture flow sheet shown in figure 1 in the next slide applies to all sorts of electrode products. It may vary with the raw materials used as well as with the technological equipment available. My dear friend, I have made this flow sheet with too much efforts, so you please observe this flow sheet very carefully by pausing the video. So just keeping on. Electrode manufacture is characterized by numerous operations of considerable duration, which in the manufacture of graphitized electrodes take about 2 months. Carbonaceous materials used for the manufacture of electrodes, that is anthracite, coke, graphite and coal pitch, are stored in special, usually closed storerooms to prevent them from becoming damp and soiled. My dear friends, I have made this flow sheet of electrode manufacture with too much effort, so I would request you all to please do watch all the steps very carefully of this flow sheet of electrode manufacture. It will help you a lot. Okay, now let's proceed. Anthracite is the basic component of carbon electrodes and anode paste for self-baking electrodes. It has a high carbon content, great mechanical strength and low ash content and is of low volatility. Anthracite, which has gone through thermal treatment in special furnaces, is called thermoanthracite. The use of thermoanthracite in electrode manufacturing works makes it possible to substitute drying for calcination. Anthracite is considered suitable for the manufacture of thermoanthracite, that is electrode and foundry grade, when it is strong and thermally stable, possesses high specific gravity, dense homogeneous structure, fine-grained fractures and is free of lamellar pieces and noticeable cleavage. Now let us discuss about the quality specifications of anthracite, which is used for the manufacture of anode paste. First, ash content, the maximum value should be 5%. Sulfur content maximum should be 2.5%. Strength, that is shatter index, should be over 70. Thermal stability index should be over 60. Specific gravity should be over 1.5. And size of lumps should be in the range of 50 to 120 mm. Fines, that is lumps of less than 50 mm, should be less than 5% or below. Anthracite should not contain lumps of pyrite or barren rock. The quality specifications for the electrode thermoanthracites are as follows. First, moisture, the mean value should be 0.2%. Ash content, the maximum should be 5.0%. Sulfur content, maximum should be 1.9%. Volatile matters content, maximum should be 0.3%. Lumps larger than 40 mm, that is Trommel test, should be minimum 70%. Specific electrical resistance, that is ohm square millimeter per meter, should be below 1.000. Size of lumps in mm should be 25 to 100 mm. Fines content, lumps of less than 25 mm should be 5% or below. My dear friends, just to interrupt you all, here I would like to emphasize on some special important aspect of Knowledge Galaxy. Here specialized subject-wise coaching classes and topic-wise doubts clearing are available. I am available for all of you to clear all your doubts, and especially for Diploma Engineering, Metallurgy and Mechanical students, Indian Institute of Metals, that is IIM, Part 1 and Part 2, and competitive and recruitment exams for GATE, SAIL and various other government and private sector companies, metallurgical industries, working and aspiring professionals. Here I would like to emphasize that whatever queries and doubts you are having in your mind regarding any subject or topic of metallurgy or any other ferroalloys production, operation, maintenance, so you can contact me for getting your doubts cleared. I will try to provide you accurate knowledge and to the best possible extent at the very shortest period of time, so that you can gain your knowledge, clear all your doubts, so that you can grow in your career, whether it is academic career, whether it is professional career, and so that you can develop and grow. So to continue with, here complete syllabus coverage for the students aspiring to appear in the forthcoming semester exams, that is December or June, I will be providing you all. So please contact me on knowledgegalaxy26@gmail.com or WhatsApp me on +91 99 071 44101 for scheduling and organizing the classes or getting informations to clear your doubts via video conferencing, call or WhatsApp. My dear friends, you might have encountered that you might have been having many of the doubts regarding process, technology, why they are doing, why it is done, how it is done. So, and if you don't find any answer to them and nobody is there to guide you properly, so my dear friends, I am here available to guide you all, to make you know and grow, and so that you don't have any doubts related to your process, products, technology, syllabus, and I will make sure that all of your doubts get clarified and you know the topic and subject very well and completely. So again, let's move on. Okay, now coming back to track. Coke is one of the chief raw materials used for the manufacture of electrodes, particularly graphitized type. The most valuable are petroleum and coal tar pitch cokes. Petroleum cokes are solid products obtained from petroleum residues by a high temperature process. Pitch coke is obtained by carbonizing coal pitch. Pitch and petroleum coke are distinguished by a low ash content below 1% and low volatile matter content. Coal coke is the product of destructive distillation of some grades of coals in coke ovens. It has a higher ash content, that is in the range of 8 to 18%, and is used for the manufacture of carbon electrodes, that is foundry coke. The so-called coke fines are used as a charge component in graphitizing furnaces. Graphite, when added to the anode paste, enhances its plasticity, making pressing easier, thus permitting denser products to be obtained, and increases electrical conduction, thermal conductivity, and heat resistance. Ash in graphite should not exceed 10%. Coke characteristics are given in the table below. So these are the technical specifications of various grades of coke. I have populated this table with a lot of effort, so I request you all to please, you can pause the video and observe all the data presented in this table. Okay, let's move on. Coal pitch is a solid, lustrous black in color. Its specific gravity ranges from 1.245 to 1.299. Coal pitch is used as a binder. Pitch is sometimes stocked in liquid form in specially heated hoppers called pitch conditioners. Another type of binder, that is coal tar, is stored in underground heated reservoirs in the binder store yards. This viscous liquid is a byproduct of coke. Now let us consider the manufacture of graphitized electrodes. Raw materials are initially crushed by roll and jaw crushers, which are shown in the next slides, and then they are calcined. Calcination is a thermal treatment of carbonaceous materials at high temperatures and without air access. All carbonaceous materials used for the manufacture of electrodes, with the exception of graphite, are subjected to this treatment. This operation increases apparent and true specific gravities, electrical conductivity, and mechanical strength, and reduces the volatile matter content. So this is the typical view of roll crusher, how a machine of roll crusher is seen, and various parts are also mentioned in this picture. Moving ahead, this is the picture of jaw crusher. Different parts are also mentioned in this picture. Now, it is carried out in furnaces of various types. A retort calcinator widely used in the former USSR is shown in the figure in next slide. Calcinated materials are crushed in crushers of various types and in ball mills, and are subsequently classified with the aid of rotary sieves and rocking or vibrating screens. Conditioned materials are precisely proportioned and conveyed to the mixing machines. A homogeneous mixture called electrode or anode paste is obtained in these machines. It goes either for the subsequent manufacture of electrodes or is considered to be a finished product. So this is the picture of retort calcination oven used in the USSR, former USSR, and different sections are also mentioned in that. The paste meant for the manufacture of electrodes is conveyed to a large mixing machine which acts as a conditioner and in which the temperature of the paste is leveled out. Anode paste products are obtained with the aid of hydraulic presses by two methods. First, pressing with closed impression dies, and second, extrusion of the paste through a nozzle, the broaching method. Preliminary pressing is usually done directly in the press container, which increases the compactness of the electrodes and levels out the pressure in the operation. Pressed, that is green electrodes, are water cooled on special rolls. Green electrodes acquire mechanical strength as the result of baking. Their electric conductivity and thermal resistance are drastically increased. Baking is effected at 1200 degrees Celsius in neutral atmosphere, which preserves the electrodes from being burned and deformed. Coke fines are used as a filling. Baking and subsequent cooling lasts from 16 to 30 days. As you can see that this is so much time consuming process step, so it requires a lot of effort. During this period, the binding materials are cooked and the electrodes acquire properties mentioned above. The baked stock meant for the manufacture of graphitized electrodes is graphitized in electrical resistance furnaces at 2500 degrees Celsius. The resistance elements are the electrodes themselves and the filling. The furnace, as shown in the figure of next slide, consists of a rectangular trough, one lined with firebrick and two end walls, through which pass the current carrying electrodes. A mixture of carbonaceous materials is rammed in the trough to form a tamped hearth. The electrodes subjected to the graphitization are laid on the hearth between electrodes perpendicular to the furnace axis. So this is the diagram of graphitizing furnace. You can pause the video and observe its contents. I have already mentioned these particular elements of the furnace. One side wall is made of firebrick while the other is of concrete blocks. The space between the electrode charge and the side walls is filled with heat insulating material. A layer of insulating material also covers the electrodes. As the result of graphitization, the products acquire valuable graphite properties, sharp increase in electrical conductivity, heat conductivity and chemical stability, diminution of hardness. The electrodes are readily machined, this ensuring the accuracy of nipple joints. An additional operation, that is soaking, is effected to improve the physico-chemical properties of graphitized nipples and to increase their compactness and toughness. Baked stock is soaked with pitch in autoclaves at 200 to 300 degrees Celsius and 5 kg per square centimeter pressure for several hours depending on the cross-section area of the semi-product. After that, the latter is graphitized. Baked carbon and graphitized electrodes are then machined. This operation consists of turning the outer cylindrical surfaces of the electrodes and the electrode ends and of threading nipple joints. A nipple joint comprises a cylindrical nipple with a screw thread and a nipple recess in the butt end of the electrode. Nipples are threaded from special stock of both high compactness and mechanical strength, as shown in the figure of next slide. So this is the picture of electrode nipples. I have just explained about them. Conic thread is often used for carbon electrodes. One end of the electrode is threaded with a conic nipple while the other is a corresponding socket. Electrodes are expensive because of this complex technological flowsheet and the high cost of raw materials. The higher cost of graphitized electrodes is explained by the necessity of effecting an additional operation, that is graphitization, which consumes a large amount of electric power, approximately in the range of 6000 kWh per ton. I hope this clarifies why the graphitized electrodes are not preferred for ferroalloys manufacture. Okay. Now, let us consider about the manufacture of self-baking electrodes. The major advantage of self-baking electrodes in ferroalloy smelting are the following. The possibility of manufacturing large diameter electrodes. Second, they are low cost. Third, the possibility of adding joints without interrupting power input. And last but not the least, the possibility of their on-the-spot manufacture. A self-baking electrode is a metallic shell made of 2 to 3 mm sheet steel and filled with anode paste. The manufacture of a shell section consists of the following operations. Making of angle cuts in steel sheets, this is the first operation. Second, rolling of sheets along the cylinder generatrix, bending of sheet edges inside along the cylinder radius and bending of triangles. Third step is acetylene or projection welding of rolled sheets with an intermittent, that is not continuous, seam so that the gases evolve freely when the electrode is baked. Otherwise, the gases may damage the electrode shell. The ribs may be made separately from the shell and then welded onto it. The cylinder obtained with the ribs bent inside is approximately 1400 mm long. To facilitate jointing, special cuts are made in each section and the shells are somewhat tapered, that is the difference in diameters being 5 to 6 mm only. Inner ribs are intended to increase contact surface between the shell and the anode paste to provide adequate adhesion and to make the electrical conductivity and mechanical strength of the electrode more reliable. The number of ribs ranges from 4 to 8 depending on the electrode diameter. The rib height is increased correspondingly from 100 to 250 mm. There are not less than 4 triangles bent on each rib, the so-called tongs. These tongs strengthen adhesion between the shell and the anode paste. The shell itself is a casing for the anode paste. It protects the anode paste against oxidation, provides passage for the electric current from the electrode arm to the baked section of the electrode and intensifies heat transfer to the upper unbaked section of the electrode. Electrode paste is prepared in accordance with the above mentioned technological flow sheet in electrode manufacturing works or in special shops at the ferroalloy smelters. The various manufacturing methods give the following ratio of electrode paste consumption in percentage. Anthracite or thermoanthracite 37 to 55%, electrode machining tails or metallurgical coke 21 to 38%, pitch 24%, tar pitch 25%. These are the typical feature components. The best electrode paste is obtained from medium pitch. Electrode paste should conform to the following specifications. My dear friends, this is one of the most important part of this presentation. You should watch it very carefully and observe it. Ash content should be maximum of 10%. Volatile matter content should be 14 to 18%. The paste should be well mixed, homogeneous in composition and free of any dirt or foreign inclusions. In summers, the volatile matter content should be limited to 13%. Electrode paste is made in the form of briquettes weighing not more than 40 kg each. Electrode paste should be transported and stored in conditions precluding its contamination. The softening point of electrode paste is 40 to 70 degrees Celsius. My dear friends, now I am going to describe about the very essential properties of the electrode paste. So I request you all to please do watch and observe this part of the presentation very carefully. It should retain the mechanical strength sufficient for its processing in a crusher up to the above mentioned temperature. The electrode shell is filled with electrode paste without disconnecting the power supply. The paste is loaded as a solid at least once a day. The size of anode paste lumps emptied into the shell should not exceed 200 mm for large furnaces and 150 mm for smaller ones. And this particular size of the paste depends from furnaces to furnaces and company to company, varies, as I have mentioned in the starting of the presentation also. The electrode paste is filled to a level 4 to 5 meter above the clamps. These clamps are contact clamps. The electrode top should be covered with a lid to avoid dust, since it may lead to subsequent electrode breakage. This is the very much importance of keeping a lid on the top of the electrode casing at the electrode paste filling level floor. Separate shell sections are jointed by means of gas welding or continuous seam around the shell circumferences while the furnace is in operation. The electrode shell should be so mounted that the ribs of the jointed sections are aligned with the electrode ribs. It is desirable to weld the ribs of the upper shell to the ribs of the lower shell section. In welding shells, one must observe the following conditions. First, see to it that the welded shell section is in a vertical position. Make sure that in its maximum elevation, the electrode shell does not interfere with the stationary framework and cannot be hit by an overhead crane. In furnaces equipped with braking devices, steel bands are welded to the electrode shell with a bilateral seam 100 mm long and at intervals of 200 mm in large furnaces, and with a unilateral seam 50 mm long and at intervals of 100 mm in the smaller ones. A special platform is mounted atop the furnace to facilitate electrode joint making and filling. The heat evolving from the furnace softens the paste and enables it to fill the electrode shell compactly. Temperature for the baking of electrodes should be as follows: 25 degrees Celsius when the paste is solid. Next, 70 degrees Celsius when the paste is completely softened and melts into a solid block. Next, 300 degrees Celsius when the solidification sets in. 700 degrees Celsius when the solidification ends with the evolution of remaining volatile matters. Temperature changes occurring in the electrode paste and the way in which temperatures are distributed in an electrode during the electrode baking procedure in large ferrosilicon furnaces are schematically shown in figure of next slide. Please watch that video in that picture in the next slide. The temperature rises to 50 to 70 degrees Celsius at 2 to 2.5 meter from the lower tip of the clamps, contact clamps. By this time, the paste is completely softened and melts into a compact block, thus increasing the heat conductivity of the paste. The temperature reaches 300 degrees Celsius at the level of the upper tip of the contact clamps and paste solidification sets in. The electrode is finally baked directly beneath the clamps where the temperature rises to 700 to 800 degrees Celsius. My dear friends, please observe this diagram of temperature zones in a self-baking electrode very carefully, as it is very important to know the different temperature zones in a electrode manufacturing, and it is very much useful for you all to observe this thing, and always keep in mind. Correct operation requires that the electrode should not be baked above the clamps. For a satisfactory clamp electrode contact is obtained only when the electrode enters the clamps in a softened condition and is molded by them. The cooling of electrodes should be watched as carefully as that of clamps, for an abnormal increase in temperature causes premature baking of the paste. When the electrode begins to bake above the clamps, the operation of the open disc fan as well as the electrode cylinder and the gland gasket should be checked. Graphitized electrodes are jointed as follows. Let us now discuss about how the graphitized electrodes are jointed. First, the threaded socket of the upper electrode section is cleaned, preferably with compressed air. Second, the nipple is screwed into the utmost. Bracing hoops are put on a new electrode and a lifting plug is carefully screwed into the latter socket. Next step is the lower nipple socket of a new electrode section is thoroughly cleaned. Fifth, the electrode is conveyed to the furnace by an overhead traveling crane and mounted above the electrode to be jointed. The new electrode is lowered to a point where its nipple enters the lower nipple socket of the new electrode section. The electrode should then be rotated around its axis. It will thus be unscrewed from the plug and screwed onto the nipple. The screwing of operation should be completed with two sharp twists of a wrench or lever. Next step is the bracing hoops should be taken off as soon as the jointing is done. Now let us discuss about the operation of electrodes. It is very important to observe and know about the operation of electrodes, how it operates and how the correct operation should be done. The slipping of graphitized or self-baking electrodes in furnaces which are not equipped with brakes is effected in the following manner. First, furnace power supply is disconnected. Second, the electrode is fed down until it rests on the furnace bottom or until it rests on a freshly charged mixture. When extra low carbon alloys are smelted, it may also be supported by a crane. Next, clamps are pressed back and the electrode holder is lifted, usually 300 to 400 mm above. Next, the clamps are secured, electrodes lifted and furnace power reapplied. Before being slipped, the electrode is thoroughly air cleaned to ensure reliable electrical contact between the clamp and the electrode. There are various failures leading to breakage one may encounter in working with graphitized electrodes. Poor centering of electrode holders may cause electrodes to break in the clamps when the latter are locked. Next, poor contact in the nipple joint is quickly discovered due to sparking and local incandescence. poor contact may also lead to electrode breakage. Electrode breakage may be caused by incorrect charging or negligence as a result of direct impact on the center section of the furnace when it is being cleaned or when attempting to lift an electrode frozen in the melt. In normal operating conditions, the slipping of self-baking electrodes is effected with unbaked electrodes, this ensuring reliable clamp electrode contact. When baking electrode above the clamps, it should be slipped so as to provide contact with the unbaked electrode. Slipping of self-baking electrodes with the power on was described above. It should be noted that the use of a spring lock in electrode holders permits to slip electrodes without disconnecting the power supply. Electrodes are slipped 100 mm each shift, and this depends on the product and from company to company size of the furnace also. It totally depends on the consumption of the electrodes. This increases furnace efficiency. Moreover, spring clamps ensure uniform clamp pressure, thus improving operating conditions as a result of identical contact between the clamp and the electrode for all clamps. My dear friends, nowadays hydraulic presses are used for the electrode holder supply, electrode holder contact clamps. So nowadays technology has improved and hydraulic machines are used for all the electrode holding devices, contact clamps, etc. In operating with spring clamps, the welding of the braking device band to the electrode shell should be carefully checked, as the disruption of bands leads to breakdowns. For the electrode in this case is held only by the bands, and if the latter fail, it will drop onto the furnace. After each electrode slipping, the time and the height of the lowering should be registered in the furnace log. In normal operational conditions, the electrodes are slipped 2 or 3 times in a day in furnaces smelting ferrosilicon and silicon chrome, and every shift in those smelting all other grades of the alloys. The time interval between slipping operations for self-baking electrodes should not be less than 6 hours. The slipping height varies from 100 to 250 mm depending on the electrode diameter, the frequency of slipping, and the technological features of the process. Should there be a heavy evolution of gases following the slipping of an electrode, power load at the latter must be decreased to avoid breakage. Electrode breakage may occur because of the following reasons. When an electrode is slipped into a moist spot under full load. Next, due to rapid cooling when the furnace power is taken off. Next, due to incorrect heating up procedures following the furnace shutdown, especially the long shutdowns. Next, due to poor ramming or poor quality of anode paste, etc. Following a breakage, an electrode should be slipped to a greater length and should be baked according to a special timetable. The electrode baking procedure following the breakage depends on the condition of the remaining working tip. When an electrode breaks in a baked section, the broken part should be removed. The electrode should be slipped to the minimum length required for normal operation, and baking should be started with power input at the electrode equal to 30% of the rated. The magnitude of the current is then gradually increased at a rate which will make it possible for full furnace power input to be reached within 6 hours. When an electrode breaks in the clamps and paste crumbles out, the furnace is shut down, the damaged electrode is set on the remaining electrode and its raw tip is pressed hard against it. The electrode is then slipped 700 to 1000 mm and when possible, in case of the shell of the damaged section is intact, the damaged and the raw electrode are jointed by a steel band hook by means of acetylene welding or arc welding. Power is reapplied and braking is conducted by gradually increasing power load in the course of 12 to 16 hours. Normal baking process is characterized by dark electrode shell, absence of red spots and swellings on the shell, that is, openings are provided in the shell to permit the evolution of gases, evolution of short tongues of smoking flame through the openings. The reddening of the shell, outflow of paste and violent evolution of gases are signs of an overload. In this case, power input should be decreased immediately. The disappearance of flames shows that the baking process is over. Dear friends, I am providing you all the informations free of cost which are available in my YouTube channel. So do help me by watching all my videos. Do subscribe my channel. Regularly visit and repeatedly visit my channel. Do watch all my videos, contents, like the content, share with your friends, and so that I also get motivated from each one of you as you subscribe to my channel. I am very much thankful to all my subscribers who believe in me, have subscribed my channel and like my content. So to motivate me further, please do subscribe my channel, increase the subscriber count, share with your friends so that others can also gain the knowledge. And my dear friends, if you subscribe my channel, this will motivate me to do further better. So I hope you like the content and found the video worth. So again request you to please don't forget to like, share and subscribe the channel. Also remember to press the bell icon so that you can get the notification of the new videos promptly. My dear friends, here if you want to advertise about your product, services or company or anything else for gaining popularity in my channel, so you can contact me so that I can put your content for advertisement in my videos, forthcoming videos. So it will be a good platform to advertise. So do contact me as soon as possible. Thank you very much for watching this video till the end, and I am very much again thankful to all of you who helped me, who believe in me, and please do visit my channel regularly and repeatedly. Thank you very much again. See you in the next video. Thank you.